Okay. So we're transitioning down to the 6-5 review. Like I said, for those of you that are home, make sure that you access this because whatever we don't get done in class will be due for homework. Okay. The section 6-5 was all about rationalizing denominators. So now we're simplifying these radical expressions, but I have a root underneath in my denominator, I should say, right? In the denominator of my fraction. And this is troubling because I can't have a radical in my denominator. We kind of introduced this in a similar way that we introduced imaginary numbers. Remember, we said we don't want any imaginaries underneath our roots, and there was a couple situations that kind of came up for us there to simplify. It's the same thing here with our denominators with radicals. All right. There's a situation where you either have a constant multiplied by a radical, maybe just a radical by itself, and there's something that we need to multiply our numerator and denominator by to get rid of that. And then there's also examples, which we'll get to later on in class, where maybe I have an expression there. So a constant plus or minus a radical, or, vice versa. All right. And we'll see how there's different ways to simplify each of those depending on the situation that we get. Okay. What I plan on doing is just going through pretty much all the odds today in class. And I'll do a couple kind of on my own. We'll do some together and then kind of work through each of those two situations and hopefully give ourselves a good chance to review all those topics in preparation for the quiz. All right. So if I look at example 1 here, all right, and we haven't seen 6-5 in a little bit, so I'm going to kind of take this on my own. I have 3 root 4 divided by 2 root 5. All right. So this is a situation I don't have an expression in my denominator. What I'm going to multiply the numerator and denominator by is just that radical expression. So the root 5. Right, whatever that radical term is, I should say, I'm going to multiply top and bottom by. Okay. And my objective in doing that is to get rid of any square roots in my denominator. So this is really 3 times root 4 times root 5 in my numerator. Well, I can only multiply terms that are the same. So constant terms with constant terms, radical terms with radical terms. It's the only way that I can simplify. So this is really 3 times root 4 times root 5. Well, root 4 times root 5 is the same thing as the square root of 20. You just multiply those terms together and keep it underneath a radical. In my denominator, I have 2 times root 5 times root 5. Well, if I simplify that the same way, that's 2 times root 5 times root 5, or root 25. What's that? Yeah, just got in the hallway. So my numerator, I can't simplify that further yet. I have 3 root 20. In my denominator, I have 2 square root of 25. Well, we all know the square root of 25 is 5. What's that? So it'd be 2 times 5, yes, or 10. All right. So everybody with me so far? Everybody see how I got to that point? Well, one thing that I'm holding off from doing just for the time being is simplifying my numerator. Notice that I can break down the square root of 20 a little bit further. All right. This will become 3 times. Well, if I'm thinking about factors of 20 where maybe one of them is a perfect square, 4 and 5 would allow me to break root 20 down into 2 root 5, right? Square root of 4 gives me the 2. The 5, the term that I can't break down, stays on the inside. And then when I simplify that further, 3 times 2 on the outside, again, terms that are the same I can multiply, will give me 6 root 5 over 10. Now from here, I can still break this down further, and you're going to see this a lot in our examples as we move through today. Think about a term that I can cross out in my numerator and denominator. Well, I know that 2 goes into each of those. So it's going to be 3 root 5 over 5. for my final answer. So try and simplify as far as you can with your final answers. Take out a GCF, cross out some terms, do whatever you need to do, okay? Any questions about that first example? Let's take a look at example 3. Very similar to the first example. Again, I just have a constant multiplied by a radical. So what should I multiply the numerator and denominator by? Example 3, good, root 5. When I do that, I have the same thing as before, right? 5 times root 2 times root 5. Well, I'm only going to multiply those radical terms together. So that's going to give me 5 square root of 10 from the root 2 times root 5. In my denominator, I have 4 times root 5 times root 5. Well, how is that going to simplify? Four squared root of 25, and what's square root of 25? Just 5, right? So it's 4 times 5. And then what's 4 times 5? 20, right? As you progress through these examples, you can go from this step to this step. So you don't necessarily need to show the root 25 step and then show how it breaks down to 5, right? You can just jump from here to here. In fact, every time that you multiply a radical by itself, like the same radical, it's just going to give you whatever that number is inside. All right, so you don't really need to show this. If you do, no worries, but if you want to skip some steps, you can. What do I notice I can take away from the numerator and denominator? How does that simplify further? Take 5 out from each. And I have root 10 divided by 4. Okay. Can't break down the square root of 10 any further, although it does have more factors. None of them are perfect squares. So it doesn't help me at all. Any questions about example 3? Okay. Go to example 5. What should I multiply the numerator and denominator by in example 5? Root 3, right? Whatever that term is in my denominator, that is the radical. So root 3. How does the numerator simplify? So 5 times root 3, can I combine those in any way? Does that break down at all, or do I just kind of write them next to each other? Right, it's right next to each other. So it's 5 root 3. How does my denominator simplify? So I have 5 root 3 times root 3. It's just 5 times 3, right? Because it's 5 times root 3 times root 3. Well, root 3 times root 3 is root 9, which we know is just 3. So again, that's me just kind of going from one step to the next and not having to write down the radical. 5 root 3 stays the same in my numerator. My denominator becomes what number? 15. And then what number can I divide both the numerator and denominator by? 5, so I can take 5 out of each. I'm left with root 3 over 3. Okay. Any questions about number 5? All right, why don't you try number 7 on your own? Take like 2 or 3 minutes. All right, we're kind of in a good groove with this by now. Hopefully we can simplify this on our own. Take 2 or 3 minutes. I'm just going to walk around, make sure that we're doing the right thing. We'll go over it, and then we'll transition into the next set of problems, which is a little bit different. Okay. So we're doing number 7 here on our own. All right, let's go over this one. So it'd be root 5 times root 5, which is just 5. So it's close. And we multiply the square roots together, it's 1 inside. So it'd be 5 root 10 over 5. All right. So somebody tell me what I need to multiply the numerator and denominator by here. Root 5, good. When I do that, how does my numerator simplify? What does that become? 5 root 10. What about my denominator? What's root 5 times root 5? Root 25, which is just what? 5, right? And then what do I notice I can cancel in my numerator and denominator? The 5s. So I'm left with just root 10 for my final answer. Everybody good with those examples and everything that we've done up until this point? Okay. You're responsible for obviously all the evens, 2, 4, 6, and 8. Definitely pay attention to those. Very similar to what you're going to see on Friday. All right. A little bit of a hint for you. The other piece of rationalizing denominators, however, was when we had an expression underneath our fraction, right? So we have some constant being added or subtracted with a radical term, all right? When this was the case, we can't just multiply by whatever that radical term is. I have to multiply by what's called the conjugate, okay? We talked about that not only in imaginary numbers, but also when we were doing our rationalizing here with these denominators. So I'm going to walk through number 9 kind of on my own. All right. And I'm going to start by multiplying top and bottom by that conjugate term. You keep the terms the same. So whether there's a sign in front that you see here with the -3, that doesn't change. All right. The only sign that changes is the operation in the middle. So instead of 5 minus root 2, I'm going to multiply top and bottom by 5 plus root 2. Okay. And that's always going to be your first step. So trying to get rid of the radical term in your denominator, multiply by that conjugate. In my numerator, I'm just going to rewrite this just so it's easier to see what the process looks like. Notice that in my numerator, I have 4 times that whole quantity. Well, I'm probably going to have to distribute. And one thing I want us to note, just so we're aware of this in our review, is to distribute that term through. All right. Most of the time in our examples, we'll see constant terms in our numerator. We're going to distribute. In our denominator, I have a binomial times a binomial. I have to FOIL. So I have to go through each of those processes for each of my problems. Okay. Everybody with me so far? So if I FOIL in my numerator, I have 4 times 5, that gives me 20. 4 times positive root 2 gives me 4 root 2. Okay. In my denominator, if I FOIL, that means I multiply the first terms together. So 5 times 5, well, that's going to give me 25. 5 times positive root 2 is just positive 5 root 2. Five times negative root 2, well, that's a positive times a negative, so it's going to give me a negative. And then I have 5 root 2 again. Be very careful about your sign changes, right? Multiplying positives and negatives together. If you make a mistake somewhere, it could alter your whole problem. So just make sure you're doing it properly. I multiply the last terms again, positive times negative gives me a negative. And then root 2 times root 2 is root 4 or just 2. So anybody have any questions about how I found those terms? Okay. In my numerator, I have 20 plus 4 root 2. My denominator, what should always happen, right, just like we saw in the last examples, is your terms that have roots with them will go away. So 5 root 2 and negative 5 root 2, those inner terms will cancel. And I'm left with 25 minus 2, which is 23. And this would be my answer. So those middle terms every single time should cancel each other out.
What if you get 24?
20 plus 4 root 2 because the root 2 is still attached. Yeah, you can never add. Those aren't common terms. Think of it as like 20 plus 4x. Right? Those aren't, can't combine those. Any questions about that first example? Okay. Let's take a look at example 11. So I have negative 5 over negative 2 minus root 2. Again, I'm going to multiply top and bottom by that conjugate. Now, what's important is that we don't change the sign of every single thing. It's just whatever that term is in the middle. Okay. So this is still going to be a negative 2. This is something that came up in the last class. That's why I'm emphasizing that point. This is still going to be negative 2. But instead of minus root 2, I'm going to have plus root 2. And I do that in my numerator and denominator. All right. So be careful just to change the sign in between. So now I have negative 5 distributing that into negative 2 plus root 2. And in my denominator, I'm foiling negative 2 minus root 2 times negative 2 plus root 2. So either way, that means, well, if you're putting the negative down here, you have to distribute it through to the entire term. So then it would also be positive root 2, in which case you would have to change pretty much the entire problem from what we've done so far. So the negative sign being out in front, you can put it in the numerator, you can put it in the denominator, it doesn't make a difference. I'm putting it in the numerator, so I don't have to worry about distributing it through and then having to kind of change what I multiply top and bottom by. You're just creating more steps for yourself. When I distribute in my numerator, what's negative 5 times negative 2 going to give me? Positive 10. Negative 5 times positive root 2, what's that going to give me? Negative 5 root 2. In my denominator, -2 times -2 gives me what number? 4. -2 times +√2. Well, negative times a positive is going to give me a negative, right? And then 2 times √2 will give me 2√2. What is -√2 times -2 going to give me? Positive 2√2, right? And then what is -√2 times +√2 going to simplify to? So the negative sign that's out front in the original problem. And what I was explaining to Jake there was that I'd rather put it in the numerator and work there, because if I put it in the denominator, I have to distribute. It's going to change the sign of everything. Any questions up until this point? Okay. So I'll have 10 minus 5√2 in my numerator. In my denominator, middle terms will cancel. 4 minus 2 gives me 2. Now, there is no GCF that I can take out that will also cross or cancel out, I should say, with my denominator. So I'm just going to leave this as is. Although you can take out a 5, doesn't make sense to if it doesn't simplify further. Okay. So this here would be my final answer. Any questions about that example? Okay. Take a look at 13. Notice 13 is a little bit different. Doesn't change our process. We just have a root also in our numerator and in another term in our denominator, right? So we're dealing entirely with square roots. Like I said, this doesn't really change what we do in our process. What should I multiply the numerator and denominator by in 13? √3 plus √5. Good. Keep those terms the same, just change the sign in the middle. Good. In my numerator, I still have to distribute. What's √2 times √3? √6. What's √2 times √5? √10. Right? You multiply them normally, just keep everything underneath that root. In my denominator, when I'm foiling, what is √3 times √3 going to give me? √9, which is just 3. √3 times √5. √15. √3 times negative √5 is going to give me what? Negative √15. And then negative √5 times positive √5. What is that going to give me? So just wait, what's that? I'm sorry. Not cancel out. So we're multiplying them together. So what's a negative times a positive? A negative. And then what's √5 times √5? Just 5, right? So it should only be the case that your middle terms cancel, which we see here. √15 minus √15, those will go away. I have √6 plus √10 over 3 minus 5, which is -2. I can't break down either of those roots any further. because all of their factors are not perfect squares. Okay. So then this here, the root 6 plus root 10 over -2 would be my final answer. So in order to add them, they have to have the same thing underneath the root, which you can't create because you can't break them down any further. So it's not like multiplying where you can just add whatever's underneath there. For example, like if I had, trying to think of an example, like root 20 and root 5. I can break down root 20 into 2 root 5 plus root 5. And now I have 3 root 5. So you can only add when they have the same thing underneath that radical. Think of it like a variable, right? Like I can only add x's together. It's the same thing with roots. Okay. Any questions about 13? All right. Why don't you take about 4 or 5 minutes here and do 15 on your own? And I'll walk around to assist you if you have any questions. And then we'll go over that and then we will be done for today. So 15 is the last question here. Go through your process. Multiply top and bottom by that conjugate, simplify by distributing the numerator, FOIL the denominator. Make sure that you cross out any, constant terms, GCFs, anything like that, and always simplify as far as you can. So go through 15 on your own. Yeah. Do 15. So what can you dig out? So you can take GCF out so long as like it's outside. Like this is still outside. Yeah, so if you took it 2 out, right? So you can cross those 2, so you put 2 out. That's the GCF. Cross those out. So this is the entire. So when you take the 2 out, this is what is that. So 2 years, yeah. This is what's left. So please. Yes, because the whole point of taking GCF out is to cross it out.
So I would.
Yeah. Either way. Negative 2 minus 2. Thank you, maybe the iPhone. Negative 2 minus 2. The little term is sort of cancel. Take another minute or two to wrap up here, and we'll go over this question. Seeing some people on the right track, it's just a matter of simplifying, which is an easy fix in case we have any mistakes. Okay. For 15, what should I multiply the numerator and denominator by to start this problem? Root 2 plus 2, right? In my numerator and denominator. Good. So I know I have 2 times root 2 plus 2, and then root 2 minus 2 times root 2 plus 2. All right. In my numerator, I'm going to distribute. What is that going to simplify to? 2 root 2 plus 4. In my denominator, when I FOIL, what's root 2 times root 2? What's 2 times root 2? What's negative 2 times root 2? And then what's negative 2 times 2? Good. Everybody good so far? Well, 2 root 2 plus 4 will stay in the numerator. In my denominator, the middle terms will cancel. 2 minus 4 gives me negative 2. Now, a lot of people just left their answer as this. Technically not incorrect, but we can simplify this a little bit further. All right. What do you notice that I can take out of my numerator in each of those terms? What's that? In my numerator? Just positive 2, right? And that leaves me with what inside my parentheses here? Root 2 plus 2. So there's a GCF you can take out of each of these terms, right? If there's a constant term, you can't take anything out of the radical here, but if there's a constant term on the outside and a constant term over here, you can still take a GCF out, which is 2. And I have root 2 plus 2 over negative 2. Well, how does that simplify? What can I cross out in my numerator and denominator now? The 2's. And I have negative root 2 over root 2 plus 2 over negative 1, right? Because that negative sign's still there. Just because I cross these out doesn't mean the negative goes away. My final answer should be negative root 2 minus 2. All right. So yes, if you got to this point, technically you simplified correctly, and technically there's no radical in your denominator, but there's a more simplifying that you can go through in order to kind of finish this problem off. Okay. Any questions about this last example or anything that we covered today in class? Okay. Your homework for tonight is to finish the 6-5 review. So you're doing all of the even problems essentially, because we did all the odds now in class. When you come into class tomorrow, we will go over the 6-5 review, and then we're going to continue on with section 6-6 and the review for that. Tomorrow's class, like I said, we'll go over the homework. The review itself is relatively short. So we're going to take a couple problems to go through for each section. And then whatever remains will be due for homework. Okay. Very similar to what we did today and what we did yesterday as well. Are there any questions for me about the assignment for tonight or the expectation for tomorrow's class? Okay. Well, then with that being said, those of you that are home, you can go ahead and sign off. Those of you that are in here, we have the bell to ring, which should be in a minute or two. Enjoy the rest of your day. I'll see you all tomorrow.